Christina, you're in now, hopefully. I don't know. The whole thing freaked out. Can't say why. But hopefully people start filtering in. Really? It's that exciting? Oh, no, I don't want to have a discussion about faith in ceramics. I already got stuck in one of those earlier today, and I can't deal with another one. And now everybody's quiet, though. Okay, we got Sandra, we got Grace, we got Rebecca. Hi, everybody. Okay, hopefully this time it doesn't screw up. Like I said,
the link that you gave on the other chat is now is like a group, but you're not in it.
Oh, really?
Yeah.
Yeah, I had to trash everything and restart. Okay, well here comes Dennis. Somebody go back to the other chat and tell everybody.
I am.
Check their email. I know it's an amazing technological cluster something in of a world we live in. Hey, everybody's coming back. Sorry for the snafu. Thank you for everybody's patience.
Is everything working now?
I don't know.
Says you're live.
All I know is I want to keep tonight's class going as long as possible to see when Ruth fades out.
Oh, poor Ruth.
I know. Well, hey, you're the only. We've got 3 European students, and you're the only one who makes it to the Hangouts. So,
is it 2:30 over there? Ruth, what time is it?
Looks like she's typing.
Yeah.
1:30.
1:30. Oh wow. Okay. So we've got some. Who else was here that we're missing now?
Vered.
Oh, Vered. Okay.
I posted the link in that one before I closed it on my computer.
Yeah, I emailed it out to the list and I put it on Blackboard. So
Scott.
Oh yeah, there's Scott. Where's Scott? He's usually like the first person who's ever here. Scott, we miss you. I know I don't have access to the old one, and I'm afraid to go anywhere because if I do anything, the whole thing falls apart. Okay, the new one's on Blackboard, and I emailed. I mean, I can email Scott personally. Let me see if I have another email for him. No, I only have the one email. Oh no, here's one. Oops. Scott, email. Let's see if it goes to his personal email now. Oh, incoming video call. What? I missed it with Phyllis. Oh no. Oh, okay, wait. Fred's still in there, along with Phyllis. Okay. Oh wait. Oh, we got Fred. Good. We got Scott. Okay, good. I think everybody's back, except Kiara didn't make it in, so hopefully she's in as a viewer. I don't see any viewers just yet. Christina wants to say silent so she can go as a viewer. Yeah, you can still ask questions. I think we just have to use the Q&A section instead of the message board if you want to ask a question and you're a viewer.
Oh, that's how that works?
That's how that works. Oh. But then I have to make sure to pay attention to the Q&A. Okay, so we're still missing Phyllis. Well, I mean, I already sent the link out, but... Oh, shoot, and I closed my email. Of course I did. Well, let's see what it does to reload. Anyway, where were we? Okay, we talked about barium and toxicity. We talked about encapsulated stains. Where were we going after that? It was you, Dennis, wasn't it? Were you done?
Well, pretty much. I had a couple more questions. Should I just jump in?
Yeah, fine.
We were talking about runny glazes being overfired glazes. What about glaze thickness? Does that factor in at all?
Thickness definitely has an effect on a glaze and its basic gravity. Right. You know, so if you just make it too thick, you know, that it will it will run. You know, the same way that thickness also affects crazing. Oh, there's only. Oh, that's why. Oh, okay. Thank you, Christina. I didn't list the participant link. Hold on. Okay. Now all the rest of the emails are coming in angry because I'm a dummy. Sorry, guys. One second. Y'all are just going to get that email too. Sorry. Edit. Oh, I'm not leaving you out in the rain, Phyllis. Sorry, I'm getting emails now. It's all coming through. So let's see. Insert. Okay, submit. Okay, so now that link is out.
Well, my other question was about Southern Ice.
What about it?
You said there was started with an H or something, a different material. Was that
Halloysite.
Yeah, and is that a clay? Is it even a clay?
It's a silicaceous material. Okay, and the thing about halloysite is, I don't have an easy piece of paper right here. Pull this one off of the stack. Oh, look, it's a printed out version of Stull. Shockingly enough, that's what I keep on my desk. Or I've got a printed out version of Glaze Fit. Yeah, this is my life. Okay, so what's interesting about halloysite is that it is a sheet-like material like clay, but instead of staying flat, okay, it can randomly curl into a tube. Okay, and the interesting thing is that it can curl into a tube, and you can get either the positive side or the negative side out, and you can't predict which one is going to be out. On top of it, because it's a tube, your particle packing is now trying to stack tubes, which can be adequate, but can be problematic and have inherently lower density. And then you're also hoping that this one's positive and this one's negative, but you could just as easily get two negatives next to each other because it curls randomly. There's nothing magical about the New Zealand halloysite. It's just the deposit is a clay-like mineral, and it's white. And there's no reason why it's white. There is a lot of American halloysite that is just, it's not white. And that stuff just happens to be one of the whitest clay-like materials on the planet.
Is it related to Fuller's Earth?
I don't know Fuller's Earth.
Fuller's Earth is used in cat litter.
Oh.
It's mined in the Tidewater of Virginia.
Mm-hmm.
It's listed as a clay by the Minerals Resource people.
So I don't know that particular material's name, but what I can say, you guys want to hear a story?
Sure.
You ready for a tangent? Sorry, keep everybody hanging on forever. So years ago, our research lab was sort of just, we were in a tough time and we were just looking for jobs to do. So you can do freelance research, and one of the freelance projects we got was from Johnson & Johnson. Actually, I don't even remember who the company was. Actually, I can look. Who the heck was it? Anyway, it doesn't matter. The test was to see if we could improve the performance of kitty litter. Because kitty litter is just bentonites. It's bentonites with perfume and other stuff put in there, but really at the end of the day, it is bentonite. And bentonite works great because it swells when it absorbs water, so it takes up a little bit of space in the bag, and then you add the water, and it absorbs the water and takes up less space, or more space, I should say, when it's saturated. To test kitty litter, we got their product, and then we tried various chemical variations on it. Hold on. But we still needed to procure kitty litter. Well, the company, or we still needed to procure cat urine. And the company is kind enough to provide it to you. Because they have a farm. And they will send you frozen, concentrated cat urine. The way that their farm works is that they have a cat ranch, and all the cats live inside the enclosure. I'm told they have an outside space too. They live on a glass pebble floor, and they are allowed to urinate wherever they please. And the urine drains, and the solids remain on the glass pebbles. And they then collect the urine to test the clumping qualities of their litter. So I spent a summer applying thawed concentrated cat urine to various clay samples. I don't like cats very much. Story of my life. Okay, hold on one second. See, now people are now saying it's okay. Well, there are viewers in there, though. Sorry, I'm still getting emails from Phyllis who says she can't get in, but it's there. I see I've got 2 viewers. Unfortunately, I can't tell who the viewers are, but they're there. Okay. So yeah, so the halloysite, it's that's why it's difficult to work with, because it is not actually clay. You don't get all of the properties of clay.
Well, it threw well for me, and it's very transparent.
When you say through well, what's your
Well,
what's
I
your
could throw
definition?
thin and tall.
Mm-hmm.
And I did a big undergraduate research project, and I tested like 46 different domestic porcelains from all over the commercially produced porcelains,
Mm-hmm.
and Southern Ice beat all of them as far as how tall I could throw a bottomless cylinder of 3 kilograms.
That is true. You know, I mean, that is not the experience that I've ever seen with Southern Ice. But you know,
But I don't think they sell it in the United States anymore.
No, it was being imported by Laguna, and Laguna stopped importing it. And I think they've now got their product called Frost, which is their equivalent substitute. I mean, honestly, I don't pay that much attention to the different brand names of clays that are out there. Yeah, and so it wasn't worth importing, which is always the question with clay. I mean, there's nothing expensive about any of our clay-based materials. I was doing the math with my wife about what they spend on their raw materials at the tile company, and I think she finally came to that they spend $7 or 7 cents a pound for clay. Of that, 5 cents is shipping.
Right.
You know, and they get it by the tray because they get it by the rail car. You know, so they get rail cars directly from the mine.
How big is Laguna's mountain of Gerstley borate out in Death Valley?
I don't know. It was pretty big when I was there, but that was 2001, so.
Oh. Yeah.
It was a while ago. You know, as far as I know, they have a good supply, but you know, I have not asked what the actual volume is, and I don't know whether they would tell us even if we did ask.
Well, then there was rumors about Graulig running out.
Um,
Is that it?
Well, what had happened? I have not heard rumors of Grollig running out. There was what happened several years ago, where Phyllis is here. Hi, Phyllis. Um, where several years ago, um, all Grollig in the States is imported by Hamel and Gillespie, which is in New Jersey, and somehow they have the contract with Imerys that they import all of it. And Hamel and Gillespie and Standard got into a fight because Hamel and Gillespie was sold and the new owners wanted more money, and there was a spike in the price of Grollig at that point. And so Standard said that they weren't going to pay it. So they started buying a different product that goes by the name of Goonveen and pitching it as a Grollig substitute. It really wasn't, and they sold that product until they settled their spat with Hamel and Gillespie, and now they sell Grollig porcelain again.
You're feeling okay? Yeah, we can do that. Okay.
I feel fine, thanks. Sorry. I'm the eavesdropping terrorist. Okay, so I see Christina has a question, and I hope she's there, but I will get to your question, Christina. Don't worry about it. Anything else, Scott? Or, I'm sorry, Dennis. Jeez, I was talking to Dennis.
No, that covers everything.
Okay, good. Okay, so Christina's question. So Christina has an interesting question because she is dealing with formulas that she got from the European Ceramic Work Center. And so she is dealing with lead-based glazes. And she's got a glaze here that is glossy. I got to go back. Sorry, I'm going to freak everybody out. Let's see. She says it is a glaze that reads on the UMF as gloss and is glossy at 1040C, but when fired to 1040C and cooled slowly, it is a matte surface. When, how, why? Well, I suspect that the crystal formation does this happen. Okay, so this is the glaze here. Slow cooling, 100 degrees C an hour to 700. Okay, so the short answer is that I don't know. When I say I don't study lead, I am not kidding. So I don't have a great answer on that, and actually, Christina, that's why I like having you around, because I want to know more about how your performance with lead goes. But looking at the UMF, I did write a new spreadsheet, or a version of the spreadsheet for our European friends, including a lot of their materials. And that is this. And the basic formula that she had is this particular frit, 3647, and a kaolin. I just chose Grollig. And the interesting thing is what her formula is doing, and this is not abnormal for a leaded glaze. Everybody seeing the spreadsheet?
Yeah.
Okay. So the interesting thing is she's talking about firing under cone 04. I mean, she's talking actually at an 06-ish, or possibly a little bit lower. And what we're seeing here is that she's got a 9.77 to 1 silica to alumina ratio, but her alkali earths are 0.99 to 0.01. There is no RO in this, or R2O in this glaze, and it's firing perfectly well at cone 04. Okay, she's got very low silica levels and very low alumina levels, and that's it. I mean, when you come and look at this glaze, it's all RO, probably a little bit of trace calcium, a little bit of trace magnesium, and trace iron, but you get the silica and alumina from the clay, and all of the fluxing takes place in the RO. And the fact is that I don't know. There is not a stull for lead. That said, what my first guess would be, okay, if I had to think about this critically, is that as we change flux ratios, and hold on, I'm going to have to open another presentation. Oh, actually, no, yeah, it's in this one. As we change our flux ratios, right, which is not that lecture, it is this one. Okay, Stull moves in and out. Okay, as we go from more R2O, or I'm sorry, more RO to less RO, the glaze region bulges out and it sort of starts to absorb that 5-to-1 line. It now sort of becomes maybe 4-to-1, maybe 3-to-1 as we push up our R2O levels and push down our RO. The converse is also true. As we expand our RO levels, okay, this matte line comes in. Okay, so instead of 5-to-1, it's potentially 6-to-1, 7-to-1, right? Because it just expands and contracts as you change RO to R2O contrast. So if we're looking at a glaze that is 100% RO, and I don't think, I have tested plenty of glazes that are all RO, but I don't believe I've ever done a version of Stull that is 100% RO. But what I would guess is that you combine the encroachment of the RO level to changing the shape of the map. Excuse me. Uh-oh, did everything just freak out? Am I still here? Are we still recording?
Black.
I went black. My camera just freaked out.
Freak out.
Oh, okay, here I am again.
Oh, no.
Okay. I don't know. I got to replace this camera. I think it's done for. Going back to her actual her actual silicon alumina levels, they're very, very low. 0.24 alumina and 2.31 silica. Now, the one thing to note is that as you go lower silicon alumina ratios, do I have that plotted here? No. Sorry again, just let me find the right slides. Open. Oh, stop. Computer lecture, Seeger install. Okay, so as we start to converge our ratios, right, that in this lower region it becomes very flexible as to what the matte and gloss lines are. As they start to come very, very close together, that they can move back and forth very easily. So she's down here at about a 9-to-1 with a compressed matte line, right? Assuming that this holds true for lead as well, and now all of a sudden that her glaze is here, and so it's going to be glossy, but if you give it the opportunity to crystallize, that it will precipitate just a little bit, and that would be my guess as to what is exactly happening. So let's say theoretically you wanted to remove this behavior. What I would probably do is to keep the glaze consistent and just move up the alumina level. So instead of going 0.25, try 0.3, 0.35, 0.4, and keep the silica to alumina ratio the same. So you may need to add a little flint as well, and to see if it continues to precipitate when you do that slow cool. And if it does, then I'm completely wrong, and if it doesn't, I was right. So, and then it just means, if I'm wrong, it just means there's more studying to do on lead. And unfortunately, I think Christina's purely in viewers, so I can't get her response at this point. Oh, with a Q&A. Oh, if you ask a question, oh, here we go. Let's see. There is a bunch of questions. Christina is listening. I should also mention that it's very runny and is more so when glossy, but both in glossy and matte. So that means it is precipitating crystals. Okay. So I'm sorry if I don't know if everyone's seeing this part. I've gone over to the Q&A section. So Christina says I should mention that it is very runny, more so than when glossy, but in both glossy and matte states. So runny as a gloss or runny as a matte is good. Okay, that means you are actually precipitating crystals. If the glaze runs and it has crystals in it, I'm sorry, if the glaze is a gloss and it runs, it can still precipitate crystals, and we looked at that last week, where you can have matte glazes that run to gloss because it's just the underlying glass running and the crystals not running, or the crystals can't run with the gloss too. So that is absolutely applicable. And then it just comes down to the question of, if you increase silicon alumina, does it continue to perform that way? And I don't know. I literally, I don't want to be stepping out from my responsibility, but when I say I don't test lead, I don't test lead. I've probably fired 10, 15 lead glazes in my entire life, and I don't have them documented. If somebody can find a version of Stull that references lead, I'd love to know. The one thing I would go back and show is that, that the interesting thing is that lead does violate Stull in that this glaze, obviously, as Christina said, fires perfectly well at cone 04, and that's historically what lead is used for. I've mentioned that a lot of industry uses lead glazes. Oops, am I sharing the screen? I'm not even sharing the screen. I'm pointing at things that I'm not sharing. So again, she's saying that this is firing off at cone 06, and I obviously I believe her, because the same way that we can do things to change flux ratio and add boron to change temperature, lead, pure lead, Dr. Carty always says lead is the closest thing to magic, because it does violate many of the rules. One, you don't need an RO, or I'm sorry, an R2O. It works purely with pure RO. It's incredibly stable. It's low temperature instead of high. This is functioning at low temperature with 0.99 and very glossy. But I outright do not know if the rules of Stull apply to lead. I suspect that they do, because we're still talking about fluxes, silica and alumina. We're talking about precipitating crystals. So, I would believe that all that is true. So what I would potentially try is, if this is 15, there you go. So take it to 20, Graulig, and then add in flint, just standard flint, to 5, so 7, right, to get it back in line. And now you've got the same basic flux ratio with increased levels of silicon aluminum. It should decrease the running and theoretically eliminate the crystals, but again, I cannot say definitively. That's just my speculation. And let's see if Christina has a response. 48 Custer. What's this formula, Christina? Oops, sorry, everybody. Freak out. She's got a different one I'm going to plug in here while I talk. Custer. Custer, EPK, Whiting. Silica, 48. $20. 20. 12. 20. All right, 6% copper. Oh no, that's 12. Right. So she's entered another formula. Oh, that's Kiara's question. Oh, this is weird. It's flowing from the bottom up. Oh, I'm sorry, you guys. I'm totally confused. Okay, so we've jumped now to. So Christina jumps back and says she's actually trying to keep it matte. If you're trying to keep it matte, Christina, okay, let's see. If she's trying to keep it matte, so screen share. Okay, let's see what we do with the numbers. If you're trying to keep it matte, yeah, I would just go back and increase the clay levels, 20, 30. Yeah, I mean, I would just increase the clay levels, and it will take you, right? This ratio keeps dropping, which should force it to be more matte if Stull applies. This might get a little thick, so you may need to add a dispersant. You may need to add a couple of drops of Darvan to thin it out. But I mean, if you were at 15%, try 20, 25, and 30%, and see how those perform in the studio. It should work, but I can't say definitively. Okay. So let's see. Ruth, I see your question. I'll get to you in 1 second. I've got a question from Kiara here. In the messages, in the Q&A. Let's see. Okay, so Kiara's question. The formula I'm working with is Kiara's. Yes, got it. Okay, so that is Kiara. Sorry, guys, this is all backwards. So if I select that, okay. Okay, Kiara, what's your... Okay, if I have 0.25 alkali metal to 0.75 alkali earth with a 6.26 to 0.75 ratio, I have a matte glaze. I don't follow the 6.26 to 0.75. This ratio should always be 1. That's how you define the ratio. I'm not sure how you got the points. Oh, are those your actual level? No, that's not your actual levels. I have a matte glaze. If this glaze has 6% black copper oxide, which I think is fluxing but no boron, and I add boron to make it a safe cone 6 glaze. Okay, I think I understand the question. Okay. So, Kiara has this glaze. Right, I know. It's a little crazy. Okay, so she's got this glaze here with 6% copper oxide. Okay, so she's got a 6.26 to 1 silica to alumina ratio, 0.25 alkali metal to 0.75 alkali earth. Her silica level is 3.34. Her alumina level is 0.53. And she's saying that this performs as a matte glaze with copper oxide, I believe she said, at 6%. My question has to be of do I think that this is an actual matte glaze at cone 6? No, I don't. Even with the copper, and that is a lot of copper, which could theoretically have fluxing potential. The question then becomes, is it going to be a true matte? And what I would say to try is what I have just done of just mix this without the flint. Okay, just take that flint right out. Now you're under 5 to 1, right? And you will know a lot more about if you are melting or not. Because you've now moved, if you're crystallizing or not, because you've now moved into the crystallization range. That would be my first test to check the validity of this. So back to your original question, if you add in boron, can you make it work? So let's just go. I mean, we'd sort of done this last week. I think it was your question, Dennis, of can we add in Gersley borate and make a glaze sort of convert to cone 6? And I think we'd sort of said, well, yeah, to a certain degree, you can. So adding in 12% Gersley borate, take the flint out again, because the flint's not doing us any good as far as making this matte. In fact, it's keeping us back a little bit. Our flux ratio is changing, but I'm not real panicked about that. We are not quite under 5 to 8. I'd like it a little bit farther to get that stable some more. So I'd probably say increase the clay. That's going to bring in alumina, which is going to make this more matte. So I take us from 20 clay to 25, right? And now we're under 5:1. We've got some boron in there. Our flux ratio is fine. I would be happier trying something like this. Okay, so 48 Custer, 20 Whiting, 25 EPK. I'm sorry, 25 EPK and 12 Gersey borate. And I should have read the normalized version. 45 Custer, 19.5 Whiting, 23.81 EPK, and 11.43 Gersey borate. That's probably what I would try. But like I said, try that first variation of just taking the flint out and see what it does. Okay. Well, let me know in the viewers if you have more questions. I'm more than happy to answer them. But okay, so what else have we got?
Can you go back to bubbles, pinholing, cratering?
Mm-hmm.
Okay, and I have always understood pinholes as the tiny holes, and then craters as the bigger ones, and the craters can either have rounded edges or sharp edges.
Yes.
We're okay on that. Okay. Descriptor. Okay, so in what kind of glaze are you more likely to have this occur? Where do you see it? With any kind of particular addition of certain materials over other materials in your ratios? Where?
Yeah. Going back to Dave's research in the lecture about pack bed porosity as a cause for pinholing. That definitely becomes a concern with certain variables. MgO sources tend to pack worse. So talc, especially mag-carb, magnesium carbonate, those tend to make packing worse. Zinc definitely makes packing worse. And notice that those both go to the crawling system that we had talked about, where you get high shrinkage combined with the small ionic size material, and it shrinks a lot. It does come down to the mixing, the particle packing. The other thing that often gets ignored is that it also comes down to the bisque in the application. The most common thing to do to eliminate those types of a pinholing problem per se is to add dispersant to your glaze. By adding dispersant to the glaze, just a couple of drops, it then packs all those layers tighter, it compresses them together, and you don't get as much of that packed bed porosity, which is sort of the problem that Dave is talking about. Blistering and bloating is a real thing. Usually when those are done for effect, they're done with silicon carbide. Okay?
To get like your crater glaze?
Right. And the crater glazes work with silicon carbide because silicon carbide is a very high temperature material, but it's also material that has to exist in reduction to be stable. Okay? If you fire silicon carbide in a normal atmosphere, the silicon bonds with oxygen to form silica, and the carbon is given off as carbon gas. Okay, and then that turns into CO2 as well with the oxygen in the atmosphere, and then that causes bubbles.
When you talk about mixing, are you saying like sieve, because I generally sieve with an 80, so sieve at 100 or 120, that's going to get it better mixed?
If you think it's a better problem. I mean, if you think it's a problem, yes, a finer sieve can help, but sieves are really just breaking up agglomerates. They're really just breaking up chunks. When I say a better mix, I mean make sure to use an immersion blender or a milkshake mixer, something very, very fast. Because that will break up the particles in the glaze suspension as is.
Okay.
But especially the other material to look for is high clay. I mean, we were just talking about glazes having high clay content. That makes them very thick, and because clay in suspension is non-Newtonian, means it doesn't apply to the laws of physics. Don't apply. It just keeps floating, and the particles keep bouncing off of each other. They don't arrange themselves as nicely when you apply it to the surface of your bisqueware, and that can cause more bubbles. So high clay can definitely be an issue as far as pinholing.
Okay. So, and a dispersant, Darvan?
Yeah, Darvan.
Okay.
Anyone will work.
Okay. So, if I'm understanding this correctly, you said that it's not an off-gassing issue because a lot of that stuff is driven off earlier in the firing cycle.
The vast majority of it is driven off in the bisque, or
Right.
early, or in the clay body, or earlier in the glaze firing.
So, where are these bubbles coming from?
They're there. That's the whole catch. They are there in. They're not bubbles. They are pockets of air, of negative space inside the particles of glaze. Because before it's fired, the glaze is still a chunk of clay next to a chunk of feldspar, next to a chunk of quartz, next to a chunk of clay. There is negative space in there.
Ah.
And so all you're doing is when you form these bubbles is you're literally just trapping that air inside the glaze as it melts. Okay? And then those pockets of air expand and contract as the temperature goes up. As far as the degradation of other materials, the only other thing that really becomes an issue is iron. Okay? You know, I was in a very long discussion today online with people that were trying to claim that strontium breaks down in the firing, but there's zero proof of strontium breaking down in the firing at temperatures that are relevant to bloat. Iron definitely goes from Fe2O3 to FeO, which theoretically is releasing oxygen at that point in the reduction, but that's also often why you may do body reduction, to force that reaction earlier in the firing so that you don't off-gas in the peak glaze firing. Because if you are off-gassing, it can cause bubbles. And iron can off-gas because of its multiple valences, going from Fe2O3 to FeO. And this is the reaction that's generally attributed to tea dust glazes, where they're only fired in oxidation, okay? So they don't have a body reduction cycle. And what it's relying on is that there's something called vapor pressure, which is a certain temperature where materials will naturally change their valence. And for iron, for Fe2O3, it's around cone 5. Okay, where it will just naturally go from Fe2O3 to FeO. And so what an iron spot glaze is forcing is that it's keeping it Fe2O3 all the way until it hits vapor pressure. And then it naturally degrades into FeO, which then causes bubbles which change the chemistry locally. And it's sort of the same way that an atmospheric firing can change the chemistry locally. You hit that pot with salt, and all of a sudden you've got a different glaze. That when you change the chemistry locally, introduce this FeO into your glaze, you can get localized crystallization, which is also called phase separation, which is incomplete crystallization. And then that can cause the tea dust effect.
I thought tea dust was pyroxene crystals that were precipitated out in after a reduction fire during the cooling.
I mean, the tea dust that I know are all oxidation glazes.
Well, the tea dust I know is on 10 reduction glaze.
Let me see if I can. Does Wood have a picture in here? You know, all that Temaku, it's all very dangerous to force that into reduction because that Fe2O3 to FeO reaction. It can be very violent. And actually, I talk a lot about that in clays because what is often attributed to as black coring to carbon release in a firing is actually just the conversion of iron inside the clay body and getting incomplete iron reactions. Anyway, I shouldn't spend the class looking here. Just happen to have it near me. But anyway, no, all the sort of the Temuku iron, all of that, as far as I know, is oxidation. But if you've got reduction formulas, I'd love to see them.
Okay. Well, I'll see if I can't fire it in oxidation and see what happens. Because I've always just fired them in reduction, and they've happened. I never thought twice about it.
Mm. Do you have
Matt,
another question?
I have a question.
Go for it.
Okay.
Hi, Grace.
So, can you see this?
Hold on, wait. I got to make you the focus. Okay. Ooh, bubbles.
But this is my Cone 6 Celadon glaze.
Oh, am I reading it as purple? Is that?
Yes, and this is soda fired. And this is another Celadon, different recipe. Black clay body, again turned out purple. And same clay body, white glaze, turned out kind of bluish.
Mm-hmm.
So what I did for this firing, first I reduced really, really, really heavily.
Mm-hmm.
And second, I cracked the door at around 580 Celsius.
Mm-hmm.
So opening kiln too early would affect this color.
What's in the black clay?
I don't know. It's commercial. But people are saying it has manganese. Of course, it's really
Right.
dark, really black.
That is my first guess as well, because from the color lecture, if we come back and look at manganese, and that one doesn't show real. Hold on, let me see. These don't show it exceptionally well. I need a better test. But manganese will tend to burn purple. And so I would suspect that you are getting Sorry, I'm looking at tests while we talk. I would guess, that there's probably manganese in that clay, and that it is saturating into the glaze. Do you have the glaze formula on hand?
Yes, I do. So this one, the with bubble,
Sure.
it has Coster 53.3,
3.3. Mm-hmm.
Flint 22.7,
1 second. Flint 22.7. Yep.
EPK 2.8,
Mm-hmm.
Whiting 9.4, Girth Liberate 15.6.
15.15.
Yes.
Okay.
And zinc 4.5.
4.5.
Yes.
Okay.
And
That it?
dolomite 6.8.
Dolomite. 6.8. Mm-hmm.
And copper 0.28.
Just 0.28.
Yes.
Okay. Yeah. I mean, straight up, you don't have enough colorant in there to fight against that black clay. Hold on, I'll share. The copper is a very sensitive colorant, and so why isn't it screen sharing? Entire screen. is my calculator's not showing up. Oh, there it is. Okay, it is. So, am I the predominant focus on the screen? Okay, there we go. Now we can all freak out. Okay. So here's the analysis of this glaze. All in all, not terrible. Okay, 0.24 to 0.76, a 10.77 to 1 ratio, silica 2.81, alumina 0.26, and a 0.16 boron level. When we look at our fluxes, they're split between sodium and potassium, okay, and that's coming from the Custer and the Gersley. Okay, remember Gersley has sodium in it. Custer has sodium in it as well, but Gersley has more. And then the interesting thing is the RO picture. We've got 3 different ROs going: 0.5 calcium, 0.14 MgO, and 0.12 zinc. And then you said it's fired in soda at cone 6.
Cone 6, and I forgot to mention, but I tested 4 clay bodies.
Mm-hmm.
This is black, the other ones are red, like brown. They are all turned out purple. Not
Are
just
they,
this
is
clay.
just that clay?
No, not just this clay, just with all clay, it turned
Mhm.
out like this.
It turned out purple.
Mm-hmm. I was guessing it might be the, I don't know, the timing that I opened the kiln, or heavy reduction. I don't know, because I checked the test tile,
Mm-hmm.
it was light blue.
Right, and it should be low amounts of copper.
Mm-hmm.
Right, they well, actually, I know these copper tiles are pretty burned out, but low amounts of copper is blue. Right, almost independent of what the RO is. So that would be expected. Sort of stuff like the glaze itself is somewhat opaque, it looks like to me. Is that accurate? And I would guess that that's from the zinc and the dolomite. Okay, both of those. Remember, because the relationships between zinc and MgO are very copacetic. They really do a lot of the same things, and they both are opacified. So that's going to give you the base. But they're all purple. It sounds like something's contaminated, to be honest. If it was just the black, I would say, oh, it's the manganese from the black. But purple is such a specific color. Purple really only happens in manganese compositions and nickel. And it's got to be nickel with strontium or barium. Okay, and that's what these are. Right, with strontium or barium with nickel, you get purples. The interesting thing with nickel is you'll also get blues, but that's actually not a nickel reaction. What that is that's actually cobalt that is naturally occurring with nickel, and zinc picks up the cobalt instead of the nickel. It's a very funny reaction, but that you see that actually in crystalline glazes, where in crystalline glazes you add nickel and you get a pistachio base with blue crystals. Yeah, that's a funny one. That's very funny. Are you adding anything to your salt? Sometimes people add like borates to lower temperature salt to make it flux, or your soda, I'm sorry.
No, I just added soda ash.
Soda ash in solution? Like in water?
Half water, half just dry.
And has
even
anybody here tried to apply dry soda ash to a firing? I've only ever done it wet.
I always do it. I always mix.
Yeah.
Mm-hmm.
Anybody else?
No.
No? I mean, it shouldn't be the sodium, because even if you did add a load of sodium in here, which we can model, right? You just come in here and add in a bunch of sodium carbonate. Right. It doesn't really change anything that much that would make me see purple. Do you have a sample of the red with you, Grace, that ended up purple?
Oh, no, but they look pretty much the same.
Show that to me again. The plate with the bubble.
And not just glaze, even the white sleeve that I applied, they turned out really interesting. Like, I don't know if you can see, but it's very pearl-ish,
Mm-hmm.
orange.
Yeah.
Mm-hmm. So I can't figure out what this is.
Got me stumped.
It
I mean,
must
I really want to say that one's the body. I'd really like to see the red bodies to see. I mean, yeah. Dennis, you're about to say?
it must be Canadian materials.
I'm sorry, this is the red body.
Oh,
This
that is the
black.
red body.
Yeah, this is black.
Show me the. It's hard to see the inside of the black one then, since it's so dark. That one looks more purple to me, but it's really. I need a flashlight or something shown in there.
This is not the same glaze though. It's different celadon.
It's a different celadon.
Mm-hmm. I don't know if it helps.
A little bit, not much. Was it just one firing, or this? What were you working with originally?
This was my big test kiln.
Okay. And that formula was just listed as a celadon?
Yes. What is the name? It's a satin celadon.
I mean, I would not call this formula a celadon by my definitions,
Mm-hmm.
specifically because of like I said, the zinc and the dolomite are going to opacify that. And really, celadons are actually pretty lightly translucent.
Mm-hmm.
And like I said, the rest of the formula is pretty, even without those. I mean, the formula is pretty spot on. I'm just pulling out the dolomite and the calcium. I mean, is there a chance that the materials in your lab are contaminated, or?
I mixed few glazes, and this was the first and only surprise so far.
I mean, I would say do a test where you pull out the
materials in your.
Whoa, who'd I hear that from? I would say to do a test where you take out the copper, but there's so little copper in there. I can't even see it playing that much of a role.
So there's nothing to do with when I open the kiln, or
No, not really. I mean, it's hot, but it's not that big of a deal. The dry soda ash is interesting. I mean, the whole glaze doesn't really look that fluxed out. Which we were on the message board earlier this week talking about the chemical changes of soda ash, weren't we?
Yes.
Yeah. Soda ash can do that. But
What about some flashing in the firing?
yeah. Yeah, it could be flashing in the firing. It could be
Some residual something.
that was what I was about to say. It could be something residual in the firing. That certainly hangs around.
This kiln is new.
Brand new.
Yeah. And I was thinking maybe the gas from the black clay body.
You know, the other thing that I'm thinking, but it's not a purple. I mean, we talked about in the colors, we talked about generating the pinks. And zinc and dolomite, or zinc and magnesium, make pinks. But I mean, those two ingredients in this formula are only they're a third, 0.26. That may be part of the reaction. But yeah, it's so. Yeah, I mean, I don't want to spend all night just sort of sitting here contemplating. Let me think about it some more. It's an interesting query.
Should I send it to you?
Yeah, sure. It's an interesting problem. Let me continue to think about it. We can talk about it some more.
Okay.
As we go. Okay. Any other questions?
Well, yeah.
With your Genos. Oops, sorry.
No, go ahead.
Go ahead. Nope. I jumped in on you. You go.
Go, Scott.
Well, I was just going to ask about.
Oh God, I said Scott again. Dennis, I'm so sorry. I'm looking at Scott right on the end, and I keep saying Scott. Dennis, go. I'm sorry.
On stall, do matte glazes craze?
Yes, absolutely. Yep. So that's an interesting trick about stall. Okay, that matte glazes can run, and matte glazes can craze. Those are absolute realities. Okay. And that is because of a very interesting trick. And I know in this class we don't talk a lot about coefficient of thermal expansion. It's more of a clay problem. But one thing to note about thermal expansion is that the more quartz a glaze dissolves, okay, it brings down the thermal expansion of that glass. Okay, so as you add silica, as long as the glaze is dissolving silica, it will bring down the thermal expansion, which is why in this area where you've got very little quartz in the glass, you have crazing because you've got a thermal expansion mismatch. And as you increase silica, okay, you bring the thermal expansion back in line with the clay body. The interesting thing is that as you move up into the matte region, you are pulling silica and alumina out of the glass to form the crystals of the matte glaze. And because a true matte glaze is crystals growing in a glass, okay, you still have that vitrified glass as your base. You then pull the crystals out, and you now have inherently less silica in the glaze, and you get a thermal expansion mismatch.
The difficult thing about matte glazes is you can't see the crazing like you can in a glossy glaze.
Absolutely true. You have to ink it. Sometimes you can. If you look just right, you can see them. I'm trying to. Any of mine right here have obvious crazes. No, but I mean, I could go through tiles all night. You have to ink them, and you really want to ink for matte glazes anyway, or I'm sorry, for crazing anyway, just to make sure that it's not there, because I've had plenty of glazes, especially when trying to eliminate crazing, where I look at it and I'm like, oh, there are no crazes, hit it with ink and they show up, and literally you just get black India ink and just put it on there. Technically you're supposed to leave it for 5 minutes and then wash it off. And if it's there, it will permeate the crazes. Yep, matte glazes. True matte glazes can run. True matte glazes can craze. Yep, no getting away from it.
Well, I was trying to convert a bunch of Tom Coleman, Stephen Hill glazes, some of their Crystal Magic, strontium crystal glazes that are matte, but they have a high expansion contraction. So I was kind of working with that to get the numbers down.
Do you have a formula?
Not well. It was a few years ago now,
Oh, okay.
but it just reminded me of the question.
Yeah, I mean, you can, and again, that you can move around your matte glazes. You can move back and forth within that matte region. Just try to keep your ratios the same. As long as you keep your flux ratio the same and your silicon alumina ratio the same, you can change the actual levels of silicon alumina and still get crystallization with less crazing. I mean, the other thing you can do is alter your clay body, but that's a bigger discussion.
I'll have to take the clay class for that.
Although I have to tell you, I encourage everyone to take my clay class, but one of my members who I adore, it was really disappointed because it's a lot of testing to develop a clay body, and he was really hoping that there was a magic spell calculator. It's like, oh, here's your clay body, and it's done. And I'm like, yeah, you still have to test it. You have to make up all these samples and try them. You know, that's the downside to developing a clay. That's why nobody does it, and having to mix it yourself.
Okay.
Phyllis, did you have a question? Uh-oh, did we lose Phyllis?
No. I was waiting for you to finish. Not all Shinos are carbon trap Shinos.
Correct.
So in your carbon traps, is your soda ash just really high?
Mm-hmm. Yeah, so with the carbon traps, what you're doing is you're actually, that reaction that I've spent the whole class warning you about soluble sodium, right?
Right.
For a carbon trap, you are literally just adding in soluble sodium on purpose. And you can do it in the clay as well. Actually, I have more experience making carbon trap clay bodies. You add in high sodium feldspars along with soda ash, and you can even paint with soda ash. I mean, you can literally make a solution of soda ash and paint it on there.
Yeah, you were talking about that. It's just soda ash and water, and you just use an Asian brush or whatever brush.
I think so.
Mm-hmm.
I mean, honestly, I haven't done a lot of work with it, but you look at that Malcolm Davis work, and he would have cattails that were just painted in soda ash. I have to admit, I don't know if he did that onto the bisqueware or onto the glaze. He may have done it onto the bisqueware just for stability, but I don't know. But yeah, so and with the carbon trap, that soda ash is dissolved in the wet state, and as it dries, it precipitates out. And it tends to precipitate on areas with high surface area. So corners are especially beneficial because in a corner, right, you've got an entire surface here and an entire surface here, and they're both evaporating the water off at the same time, and the sodium gets left behind as the water evaporates. And so you just inherently have more water traveling through this volume of clay, and you just get more crystals, sodium crystals precipitating on that surface, and then in the firing that the sodium traps the carbon in the atmosphere. It's from the reduction in the kiln, not from the body.
Say that again now, that you put your ware in the corner of a kiln?
No. The soda precipitates
corner?
on the corners of ware, on sharp edges, higher surface area. Like if you've got your pot, you'll get more crystals that'll precipitate along an edge, because you've got a clay surface here, a clay surface here, but the internal volume of these two edges is shared by the same internal volume of clay. So more water is traveling through this space instead of, say, this space, right? Because this has got a limited limited volume of clay body to it.
Right.
But yeah, I mean, with the carbon trapping, or even with I think I'd mentioned last week, if I had a student who was doing stuff with, we were just dumping soda ash into porcelains, and they all turned self-glazing. It's fun to play with. It's not stable, in the best definitions of stable, but it works.
So there's a lot of discussion about drying your Shinos and how long, or do you fire them fresh, etc. Dry them in a draft, don't dry them in a draft, and all of this. And I'm assuming it has to do with bringing the soda up to the surface faster or slower, and then putting your wax there so that it doesn't come to the surface in that area. How much of that is valid?
I mean, I don't know those discussions per se, but it all sounds valid. You know, with drying, we don't really talk about drying in this class, but that drying is happening through the capillary suction, okay, in reverse. So what happens is you've got humid air surrounding your pot. Did this come up at all? Did we talk about this in the class? Sorry, I forget a little bit. That you've got a pocket of humid air surrounding your pot, right? And in the humid air, it only dissipates at the rate that the surrounding air can hold moisture. Okay, so the way to force this faster is by using a fan. All the fan is doing is that it's pushing away moist air and replacing it with dry air. Okay, and then that can just absorb more water. And so if you're forcing it, and you've got high sodium that you're trying to precipitate, you can precipitate it more evenly. Whereas if you do it naturally, this area is going to develop more crystals first, right? In fact, it's probably going to develop the majority of the crystals.
The
rim? Yeah.
You're saying the rim, or you're
yes, the rim.
Pointing to the rim.
Oh, okay. And it's the same with high surface area compared to the volume of the internal clay. Yeah, the wax resist will keep crystals from growing. What were your other ones?
Drafts, not drafts. I'm assuming drafts would speed up in the drying in one part at the expense of another.
I would. My guess would be that a draft would be more even, but yeah. I mean, you're talking about in a Shino glaze, not in a carbon trap clay, correct?
No, it's in a carbon trap Shino.
Carbon trap.
And then
Shino.
there's the whole thing about, do you like just get them dry enough to put in the kiln and then fire them, or can you let them sit for several days? And if so, what happens? Or several weeks? Does that change the amount of sodium left on the surface?
If you can convert the water from liquid to gas while it is still inside the bisque, you would then deposit the sodium inside the bisqueware and not the surface. So if you used heat, I would suspect that you would get lower amounts of crystallization because you would keep more sodium inside the body. But I'm just projecting. I haven't tried any of this.
Okay.
But all of those theories, especially the wax resist, yes, that will definitely keep it in place. I mean, if I was going to do a carbon trap, I would try to get as much sodium on the surface as possible. I would probably lean more towards the slow drying to accomplish that, but that's just speculative at this point.
I saw evidence of two pots sitting next to each other on the shelf, and more crystals growing on those two sides. They were next to each other, and that producing more crystals and carbon trapping.
So there was a pocket of moisture in between those two pots. So theoretically, they were drying more slowly in that area. Yeah, that makes sense to me. Because as the water leaves the pot, the sodium will do its best to remain in solution. And until you reach the concentration volume of the water, the salt is going to just make areas with denser and denser salt concentration until literally it begins to precipitate out. So yeah, that makes sense. By slowing it and forcing a moist pocket and then that dries last, yeah, I can see that. Let's see. Christina is asking, what are your feelings about procedures for drying glazes before firing in general? I have heard various things. What happens if you put a wet glaze in and starts firing? I load pretty damp glazes. The total water content in a glaze is pretty low in general, and I'm not trying to precipitate anything from forming. You do need to be careful again with glazes that have a lot of clay in them. They can shrink, and you don't want to force that shrinkage because the glaze can literally fall off the wall of the pot green. But I'm pretty abusive, and I don't have that many problems. As long as the bisque is good, the water from the glaze that goes into the bisque will generally get removed pretty easy, and you're not at risk for explosions because the bisque is dry. And so the concentration, the water is always going to be in an open pore network. So it wouldn't explode or anything. Yeah, you just have to be careful of the glaze literally falling off in sheets because it's too thick. Any other questions?
Matt, I had one. Go back to the pinholing.
Mm-hmm.
Is there any chance that spraying could, when you talked about the particle packing, does that kind of put air into the glaze?
Yes, absolutely. Because the way that spraying works is that it forms nodules of clumped glaze. Okay, so you actually get beads of glaze, okay, that then deposit themselves on the surface. And so if the beads are of too large of a size, they'll pack, it's all about that room full of balls, and if you get them too large, which is why getting the air pressure in a spray is important, okay, because as you alter the air pressure, you're going to alter how large those beads that are generated are, and you can see it if you overspray. You can literally see the clumps develop on the spray surface.
Right.
So most of the time, spray is okay as long as it's not too loose of a particle.
Yeah, because I've got a friend up at the studio that I work with, and I mean, she's always sprayed. She sprays a lot of her work. But we did have an issue. We use Laguna glaze, and she uses a B-mix that last fall, all of a sudden, it kind of had streaking in it. We all thought it was just mold growing in the clay.
In the green clay, it had streaks?
Yeah, it was just the wet right out of the bag. It had, kind of streaky type of thing, and we thought it was mold. Well, then when it bisqued, it wasn't mold because you could see the streaks in the thrown pieces.
Yeah.
And then even when it was fired to glaze, cone 10, we were still seeing the streaks.
Yeah.
But that also coincided when she started having these bubbles, the pinholes, and a lot of them. And it had us all kind of perplexed. We still not sure what it is or what it was.
Could you see that the bubbles were correlating to the streaks?
No.
Well, most likely what it was is poor mixing, which is, probably the second worst thing that happens in clay is just after bad compositions. And, again, the clay companies are notorious for mixing it as fast as possible, getting it out, and starting another batch of mixing. So if you get streaks of unhomogenized material, that also means that the negative part of the streak, the other part of the streak, is missing part of its components, so you're just not getting even firing by any degree. And the other part is, I mentioned that pinholing it is affected by the quality of the bisque.
Mm-hmm.
So if you're getting a different porosity in your bisque and different absorption in your bisque, it's going to absorb the water at a different rate, and that means it's going to pack less efficiently than you are used to, at least. Not that you couldn't adjust the glaze to compensate for it, but if you always make pots this way and you glaze them with a 3-second dip or a 5-second spray, and then all of a sudden that the absorption on the bisque is different, yeah, you could very easily turn that into pinholing.
Yeah, we just opened the studio back up and just gotten back to work again. and she got a couple. We have a whole new batch of this B mix clay, and now it seems to be it's all one color so far. It looks like it's a lot different than it was in the fall.
Yeah, I see it all the time. I mean, it's just they don't care about mixing. And then the other problem is, that it's all mixed in a plastic mixer, which is basically a Soldner or a dough mixer, that type of mixer, even in the large companies, and that's just a terrible way to mix clay. You cannot homogenize all of those particles evenly with that type of mixing, and they don't really care.
Yeah. Okay.
The best thing that you can do, in fact, my favorite thing to do with clay, with box clay, it's, again, the bummer with clay is a lot of work, but honestly, I would take my clay and slake it down new and instantly re-wedge it and reconstitute it, just because you will then inherently get a better mix once it's been slaked down.
Okay.
I mean, like, it's totally a lot of work, don't get me wrong.
What if you were just to repug it?
Repugging is better. I mean, just to the degree that anything is better, immediately after a plastic mix. But the whole thing is the thing about clays is mixing is so ignored, it's unbelievable. Okay, because we have a pound of clay, just 1 pound, has billions of particles in it. And clay performs because of the interaction of one microscopic particle to another. And we mix it in such a way where we basically just jam them together and don't disperse them homogeneously. Okay? And because of that, you get streaks and you get pockets of feldspar and pockets of quartz, and you get poor packing of your clay body and all of these conditions. And it's infuriating that this is ignored for the products that are sold to artists. Every industry that wet processes plastic clay, except for the tile industry, they don't, but they've got different practices. They all use filter press clay, and that's just clay that is mixed as a slurry. The excess water is extracted, and then you have plastic clay. It's a slightly longer process. It's equipment that most people don't have, but they all do it because they all get better loss rates. Because as soon as the clay is homogenized, it packs better. And I mean, I probably shouldn't go off on a rant. Does anybody have a question? Quick, somebody ask a question before I find this slide and go on a rant.
Well, I wanted to ask about pinholing also. I had some pinholing just over some porcelain slip that I was putting on pots, and I did a little reading about it that you can mix air into your slip, and then that comes out through the glaze in the glaze firing.
So this is a green slip or a bisque slip?
It's a green slip.
And say this again, that you can mix air.
Mix air when you're mixing the slip. You can mix air into it. Create air bubbles in the slip if you're not mixing properly, or if you don't sieve it.
Can you generate air bubbles that way? Yes. Are they going to cause pinholing? Probably not.
Well, what was strange is that the pinholing was just over the slip and not over the clay body.
Well, okay, now that is relevant because with the slip, again, talking about how bisque affects particle packing, affects pinholing. If you've got a green slip, is the green slip on top of bisqueware or on top of greenware?
Greenware.
Okay, so you are then changing the inherent packing of the slip versus the exposed clay. So if you've got slip and raw clay and they're both getting the same glaze over them, you're going to get different absorption into the clay versus the slip, because the slip has different distribution of particles, different particle packing, so it inherently has different water absorption. Does that make sense?
Yeah.
So, can you overcome that in the slip? If it was a bisque slip, it wouldn't matter. Right, if the slip had been bisqued, because then at least it's inherently open.
Oh, well, it was bisque with the pot. I mean, it was wet on
Yeah.
wet, and then both were bisque fired together.
You had bisqued them together. Well, yeah, you're still going to get different particle packing.
Well, it just seemed like it was that one batch, and since then it hasn't happened again. So I thought maybe I mixed it wrong. Or
No, I mean, maybe, but, it could be the water content of the slip, depends on how it's packed, how the slip was mixed, influences how it was packed,
Right.
how it was applied, all these variables. And it's that tricky thing of, part of this discussion I was in earlier today, of there are so many variables that are all relevant that we have to consider for procedure for that type of thing. And all of them can have an effect, and so we really have to look at each individual aspect. But I would say you're getting different particle packing for whatever reason, and that affects the suction from the suction of the glaze, the drying of the glaze, and then you get different pack bed porosity, which gives you more open pores inside the glaze. Anybody got a question?
I've got another one.
Okay, lay it on me.
I subscribed to Digital Fire about a year ago, and I put all our studio glazes in it. And there's a couple of them. One of them in particular I was playing with the other day because I was trying to figure out, it's matte, but the numbers are off. It should, according to your numbers, by Stull, should be glossy. Well, I noticed that the R2O-RO ratio does not add up to 1. It's
what?
Like, it's, it's showing 0.19 to 0.67.
0.19. Oh, well, and actually, Kiara, are you still around? Because Kiara had showed this as a ratio with different levels, but okay, what's the glaze? Or I'm sorry, well, what's the question?
Well, I tried to play with it to get the two in line, and as much as I tried, I could not get them to add up to 1. It just wouldn't happen. And then I think I may have gone and put it in your calculator. Is there a way that he's using chemical breakdowns such that the numbers wouldn't add up?
Is there iron in the glaze?
No, it's cobalt.
Do you have the formula on you?
Yeah, it's it's originally G200 feldspar, 40.65.
1 second. 40.65. Yep.
Firstly, borate 10.8.
Okay.
Dolomite 9.6.
6. Yep.
Talc is 13.2.
1 sec. 13.2.
Yeah.
Okay.
Ball clay at 4.5. And
What was the ball clay number again? 4.5?
4.5.
Okay.
And flint of 18. And the color is cobalt carbonate at 7.2.
And this is fired to what temperature?
Cone 10.
Well, I mean, I get 1.
Yeah, in your calculator.
Yeah.
Yeah, see, it's showing 0.67 to 0.19.
Sounds like a bug.
Yeah, because then I played with it, and I substituted a bunch of stuff and replayed with the numbers. And it's still, the closest I got it was 0.66 to 0.23.
No, I mean,
it
could be a bug, but honestly, I've never used Digital Fire, so I don't know how it works or what it does.
Yeah.
But no, Unity should always equal 1. My only question would be if he was including iron, because like I've said, iron actually is an RO, and I'm experimenting with calculators of incorporating it, but I'm not quite ready to release that to the public yet. Did you say this glaze is matte, though?
Yeah, usually.
Really?
Yeah.
Your alumina level's low. Hmm. My main guess would be because your alumina level is so low, again, you're back in the region where everything is blending together, and so
Yeah.
the ratios start to go gray. I mean, your alumina level is very low. I've got it at 0.26.
Yeah, well, there was that other glaze I sent you earlier in the week.
Yeah,
And
yeah,
it's the same type of deal. So
yeah. Right.
the numbers, the silk alumina is up over 10.
But you said
And,
you said usually. What do you mean by usually?
well, I think only once did I ever see this glaze go kind of glossy, but it was on a very small, very thin piece. Any other time I've ever seen it, it was always matte.
Interesting. Yeah, no, the UMF should always be 1.
Yeah.
Now I have to. Ruth has gone to bed though, but I see a question that she left that I want to get to real quick. This is a question of slow cooling. I really like very high manganese metallic glazes. I got it once but couldn't replicate it. Friends suggested slow cooling. 20 kaolin, 8 copper carbs, 69 manganese, 3 bentonite. Well, let's open up that calculator with iron and manganese in it. And look at this formula real quick. Oops. I don't want iTunes.
Now you said iron acts as a flux primarily at high numbers, high concentrations.
That's the information I don't have yet that I'm still trying to figure out.
Okay.
What exactly that percentage is. I know when you use iron as a primary material, much like the manganese, which we'll look at here in a second, it acts explicitly like an RO. Manganese 69. But where that exact line is, that's hard to say. So bentonite 3. Let's see. 20 kaolin, 8 copper carbs, 69 manganese, 3 bentonite. Okay, so this is the glaze that she's showing off, and this is pretty standard for a fake fake metallic manganese glaze. They're pretty interesting. All alkali earth, as we always talk about with any special effect glaze, you're really going to get some sort of mutation of stull. So all RO, very low alumina, very low silica to alumina ratio. That's perfectly in line with the fake glazes. So let's see. Oops, sorry. There's just slow cooling. But I once got it and couldn't replicate it. Friends said more slow cooling. So she once got it matte. What I would probably say is more clay. Again, you're going to get up into the regions of such high clay that it's going to cause the glaze to thicken. But I would almost try something like that with increasing the clay to the point where your more stable levels of glass former, and then theoretically the matte should come out more. Although even that's still low, the same way we were just talking with Scott about that lower region becomes very, very flexible. But yeah, the fake metallics, they can be severely tricky. Yeah. Okay. So Ruth had to go to bed, I bet. Any other questions?
I've got a glaze I was playing around with, and this is more about seeing if I know what I think I know. It's a 73.9 FSI, 16 whiting, 14.1 zinc, 24.5 EPK, 2.1.
Start from the beginning again, Clay.
73.9 FSI.
Okay.
16% whiting, 14.1 zinc, 24.5 EPK, 2.1 flint, and 6.5 lithium carb, and it's a 2% copper.
6% lithium carb, you said?
6.5.
6.5. Okay.
And that's it.
What temperature?
I think this is Choi Green. I think it began as a cone 10 glaze,
Mm-hmm.
and it's being used at cone 6.
Mm-hmm.
And I was asked to mix this in a workshop for somebody else.
Mm-hmm.
It just looked wonky, and then I ran it, and it's got some weird numbers. But I'm just wondering, is this sort of typical of what you would find with cone 10 glazes adapted to, or poorly adapted to cone 6?
Yeah, I mean, this is ultimately what I don't like. You know, a few of the signposts, changing the flux ratio to get the temperature down. Using lithium carb as the material to do that, you find that a lot. Not you do find it at cone 6. You find it a lot at cone 04. I mean, the number of cone 04 glazes I have that have lithium carb to bring down the flux ratio is quite high. Yeah, it's.
Well, I messed around with it a couple different ways, and got it down. Got it to where it should be. I'd have to, fire it and see. But the person I got it from wouldn't take it very well, I'm sure. But I told her it wasn't a good glaze.
Well, that leads to a philosophical discussion that we could end the class with when we're all done.
Well, she's asked me to do these workshops with her again, and I don't know, you might even know who it is, but since we're on YouTube, I won't say.
Yeah. You
But
can say after I stop recording.
Yeah, I'll tell you. You may be familiar with it, but all the glazes were just really odd. And I asked somebody who was in the workshop who actually used the glazes, and he didn't seem to think much of it.
Didn't seem to think much of it.
Of the glaze.
He just didn't care. He didn't like them.
He didn't like them, and they come out installed in the craze zone, I think.
Mm-hmm.
The way they are, and generally speaking, when you're messing with these things, I've tried to stay at true 0.3 to 0.7. There is some flexibility, but you're probably better off to peg those numbers, aren't you?
Yeah, I mean, I certainly prefer it. And again, that the stability studies I have done show that it solves that problem. I mean, the funny thing is, okay, you just take this glaze and you just remove that lithium carb, and you can start to see a different picture, right? Hold on. So
I'm not sure what the lithium's in there for.
Well, so here's the glaze. Can everybody see the spreadsheet?
Yeah.
Here it is with lithium carb, right? We've got a 4-to-1, 0.44 R2O, 0.56 RO, 1.8 silica, 0.44 alumina. So, I mean, as to your question about converting to cone 6, if you just take the lithium carb out, right, that the glaze is fine as a cone 10 composition.
Mm-hmm.
0.3 to 0.7 essentially, within the rounding error. The alumina level has gone up. The silica level has, but the ratio has basically stayed the same. You could try to pull that down by taking down your clay level. We're at 24.5. Take it down to 20. Take it down to 15. You're still well within the matte region. Take it down to 10. You're still going to get, a matte type glaze, but it's going to function at cone 10. Whereas lithium carb, my assumption would be that they're relying on the fluxing power of lithium, the concentration of lithium carb, to just bring that melting temperature down to cone 6. But I just, just talking with Phyllis, this whole question about carbon trapping and precipitation and all that. That's what you get. You know, it's going to precipitate. It's going to change the glaze regionally. You're going to get pockets now where you've got pure lithium on the surface, which is going to melt. Where, you know, and it's not going to be in the glaze. And you know, this is one of those arguments where I get accused a lot of taking all the fun out of glazes and the play and all of this, because people like glazes that react randomly, that break and that, you know, dance around and do all that fun stuff. And I know I'm the buzzkill. I'm the bad guy. But just because a glaze breaks doesn't make it awesome. You know, it's how you use the glaze. And you can make plenty of glazes that break, you know, going back to these runny matte glazes. These break like crazy because they hit an edge, the glass sticks behind, and then it rolls over. And, you know, you can get lots of break lots of different ways. It's a cheap shot to do it with lithium carb. It's a cheap shot to bring the temperature down to do that. And you're going to affect durability, straight up.
Yeah, that was clear.
Everything that I have seen, everything that I have studied, and again, I showed you guys the Cone 6 stuff, but I showed you the stuff I did at 04 last week. Durability takes a hit. When you change that flux ratio, durability goes down. It doesn't matter what the materials are. It doesn't matter, you know that you're using the carbonate. I did my tests for stability using carbonates if I had to, and glazes are stable if the chemistry is stable, and that's what it is. You know, it's not the way that I would do it. If she likes that glaze and she wants it at Cone 6, I'd take out the lithium carb, add in some boron. I mean, you know, it's just, yeah.
I did a couple ways. I threw some grossly borate in. I even tried it once just to see with Minspar, but I couldn't get it down into the Cone 6 range.
Yeah, I mean, I just threw in 20%. Oh, whoops. Throw in 20% grossly borate, and you know, you're there.
I don't think I have my other versions, but I'll have to fire them up and see what happens.
Yeah.
With the different options.
I mean, you know, yeah.
The corrected options.
The correct. Well, and again, it's not. I don't want to say correct. I don't want to say good. You know, I get accused of saying, "Oh, well, this is a good matte and a bad matte glaze," and how dare you make that judgment call? But you know, I always say that my answer is about what works. You guys can do whatever. I mean, that glaze, it works. It gets the result that they want. It's just a question of whether that is appropriate for what it's being used for.
Yeah, and I think it's going on functional stuff, so I don't know. Well, besides that, I had another question about in the salt kiln. I had a bunch of mugs done really bad, and if you marked an X on the shelf where the stuff was, it looks like a checkerboard. So I had done good, you know, like a checker, every other piece. Yeah. And some, they were glazed on the inside and outside. And it looked like they just got the daylight salted out of them, possibly. Would that cause something like that? These weren't high lithium glazes, or they were just, you know, pretty run-of-the-mill.
Excessive amounts of salt can do that. Sodium does have very high thermal expansion. When you look at the expansion of sodium, it is quite high. When you hit a glaze that heavily, it can do it. The checkerboard, you know, I can't really say with that. There's a lot of variables that would come in.
Maybe the flame pattern, or how the salt was running through the pots.
Right, one pot protecting the next, but it doesn't protect the one after that. Yeah. You know, that could totally happen. I'd need to be in there to really make a prediction. Right. But yeah, that sodium, you know, dunting in salt kilns can be a problem. And you know, what kind of clay were you using?
This was standard 101.
I don't know. Is that stoneware, porcelain?
Stoneware.
So, interesting thing about stonewares is that they often tend to be under vitrified. Usually, the generic formula for a stoneware tends to be about 90% total clays and 10% feldspar, and they'll generally just do that. That actually leaves the clay inherently underfired. It's actually not enough feldspar, even if it's 10 full percent feldspar, to vitrify that clay. I really prefer my stonewares are 20 or 80% clay, and then I get 20% for non-plastics. And my actual stoneware formula, I can tell you, it's 17% feldspar and 3% quartz, and that gives me a vitrified stoneware. But when it's just straight up 10%, it's inherently underfired, and I have all these firing curves from the clay class.
This is at cone 10.
At cone 10. Here, hold on one second. Again, not to bore everybody and not to go on too much clay stuff, but which lecture are you? Oh, and I opened the wrong one. Hold on one second. So these are firing curves of stonewares. A bunch of them are the ones that we stock in Alfred in the grinding room where we buy our clay. But some of them are commercial. Oh no, my computer freaked out. Freak out. Okay. So these are firing curves, and honestly, I don't want to go too much into the details, but this is showing vitrification. Okay. And what we've got is the green is density, the red line is absorption. In a vitrified clay, you essentially want to see basically zero absorption. The problem is cone 10 is 1300, and these stonewares are pulling 2% absorption at cone 10, and these are cone 10 clays. Here's another Alfred stoneware. This is pulling 6% absorption at cone 10. Okay, here's 570, 2%. Here's the Bray stoneware, which is pulling 1% absorption. Alfred 444 is pulling 2%. And they're also not fully densified. What this means is that the firing is not complete. And that we get. Oh, hey, there's the firing curve for Southern Ice for you, Dennis.
Yeah.
With the stonewares, this goes back to me being a crazy person about cone 6. At cone 6, all the clay companies like to say that 3% absorption is fine. But I think I showed you guys those numbers last week, that 3% absorption means you get a massive amount of variation inside the clay. The next problem is, that it's very funny that in stoneware, they're often blaming dunting on cristobalite.
Right, and that's right.
And the thing is I've actually never seen cristobalite. I've seen dunting in stonewares, but I've never seen the particular study, the machine where you look at where you would identify cristobalite is in a dilatometer, which measures thermal expansion, and you should get a very clear bump at the cristobalite temperature, and I've never seen it. But I have seen underfired stonewares. In an underfired clay, when you've got a thermal mismatch with the glaze, when you've got glazed on one side and on the inside and not the outside, when you get hit with soda, soda's salt and is notorious for dunting. I feel like, and this is just my theory, I don't have the proof, but you definitely have underfired clay, and you definitely have thermal expansion mismatch in glazes, and that is definitely a cause of dunting.
So even if the glaze is the same on the inside and outside.
Mm-hmm. But it's not. If you hit it with soda.
Right. Well, right. There's black coring also.
Which is iron.
Appears to be. There's a little bit of, there must be some iron in this clay, because it certainly turns brown. That was something else I wanted to ask you about. The reaction, when you pull a draw ring out, the clay is pretty white. And when I first started doing this, I was told that, well, the brown occurs as the kiln cools, the brown body color on the outside of the ware. Does that make any sense to you? Or?
So you're saying the stoneware looks white.
Yeah, if you pull it out of pull a draw ring out, the clay itself will be white, or buff or light gray or whatever the clay is. And at the end of the firing, when you open the kiln, you have that brown salt glaze, where the clay is bare. You have that brown.
But when you're pulling out your draw rings, you've salted it, right? I mean, that's why you're using draw rings.
Right. Checking the level of.
But are you quenching the drawing? Are you quenching it?
Yeah, and they don't change color. And I thought, well, how does this happen?
I mean, the brown color is from iron.
Yeah.
Okay. I would actually say that probably quenching may be the issue. Because... Go ahead.
Quenching the draw ring, of course, maintains that light color, and so if you left it out in the atmosphere, you think it would change color?
It may. I mean, the basic thing is, okay, so, sorry, going away from Glaze questions. If people have Glaze questions, okay, Rebecca, Sandra, raise your hands for red. Got Glaze questions. Don't let me go off on a tangent. I know, these crazy questions. The conversion of iron in a body, there's really only two things that happens, okay? Iron is responsible for all color in bodies. Iron and titanium, but really it's primarily iron, especially when we're talking about richer colors. And there are only two states. There are three major forms of iron that you can use. There's black, yellow, and red. Yellow is just red iron oxide with chemically bound water. If you heat up yellow iron oxide with a torch, it just turns red, and you use it to get lower concentrations of iron. Okay, so you get black and red. Black is FeO, red is Fe2O3, and they're different valences of iron. The natural stable form is Fe2O3, which is red or brown. The reduced form is FeO. Okay, but the reduced form is not that stable. So what often happens, especially in reduction firings, is we talked about getting to the point where iron naturally converts to FeO, but it will also naturally revert itself. It would much rather be Fe2O3 as it cools. Okay, and you'll often see this in where you fire in heavy reduction and the body is black all the way through, but the outside of the pot is red, because it is converting back to Fe2O3 as it oxidizes in the cooling. 1 second, and I can show you.
I was just reading that in Daniel Rhodes' book.
Yeah?
Yeah.
What's he say?
Well, just that it's, like the foot of your pot, and it turns that nice brown, whereas the clay is black on the inside, gray or black on the inside. It's just that reoxidation of that iron on the outside, on the very bottom of your foot, turns that nice color.
Yeah, because it's a more stable. Oh, I don't have a picture of it. It's a more stable form of iron. Oh, here you go. So this is from the Glaze class. And this is not a great example. You can only see a tiny little fraction of this, but this is a black clay body, dark clay body from a student of mine, and you can see here where it's exposed to oxygen, it's turning red again. But through the body, the complete reduction is turned to black, this is the conversion to FeO. Okay, so this is red iron oxide that was in the body. Technically, he was using yellow. When it was reduced, it's turning to FeO, and that gives you black glass. And this is a very strong glass. This is a very durable glass. It's actually better than white glass and Fe2O3 glass. And the reason why this is in here is to show this, which is he was getting crazy amounts of dunting, and this is the classic black coring problem, where it gets attributed to carbon, but it's not carbon, because carbon is long gone before any of this point of the firing. What it is he's got black glass on the outside and white glass on the inside. They have different thermal expansions because he wasn't getting reduction inside of his pots, mostly because they were lidded jars. and they just dunt it to relieve the stress of 2 different thermal expansion glasses.
Well, a couple of these are jars too.
Right.
So that could explain that. That's interesting. Well, it's a cross-draft kiln, and a lot of other odd things happen. I get crystal mats in some places, and due to, I guess, uneven temperature.
Yeah, it could be.
And then nice glossy yellow salt is a classic salt glaze.
Yeah, I know yellow salt.
Nice glossy glaze on the one hand, or serious crystals on the other hand.
I mean, yellow salt's generally a pretty matte glaze. So, if you hit it with the salt and you flux it out, change your ratio, it could turn it glossy. Okay. At least my version of yellow salt, but I haven't used yellow salt in forever. I don't even know if I have the
there's some different versions floating around.
Yeah, I don't even think I have it here.
We're having all sorts of problems with our yellow salt.
What
but
problems?
I plugged it. I mean, it runs. But our studio is, a teaching studio where glazes are just in buckets and you know nothing about them.
Right.
And every time it's in combination with something, it runs. When it's by itself, it's usually fine. But I plugged it into the UMF, and it's right. It should be a cone 10 glaze. It looks stable. It looks food safe. Like, I don't know.
Right. But it'll run in combination.
Yeah.
Which reminds me,
crazy.
Rebecca, stick around. I do want to talk to you after class.
Yeah. And it runs like crazy. Like, I last semester put it on the top 1/4 inch of like a 5-inch tall bowl, and it ran down 3 inches.
Do you remember what the silica levels were?
I could pull it up, but it'll take me a minute.
Okay. What was the other glaze?
A Celadon that also should be right. A Celadon, I think our Celadon is like our most perfect glaze if you're looking at Matt's numbers.
Yeah, Celadons generally fall right there. They're pretty consistent, pretty straightforward.
Our black and our white, on the other hand, I don't like, but let's see if I can find it.
So I will put out the call now. I see we've still got 3 viewers. So I've got the Q&A section. If you guys there, Kiara, I know you're there. Christina, you're back here. Phyllis, you're here. If you guys have questions, lay them on me now, since it's getting late. I mean, I'll hang around as long as people have questions, but, I'm sure people are going to fade out. Okay, let's see. I've got you.
Here's my yellow salt.
Yeah. Yeah, looks about right.
Yeah. It comes out matte, just barely. It runs like crazy. All the other numbers are like within our standard deviation.
Yep. And all that makes sense. Like I've said, lower silicon alumina, it can run. A true matte glaze can run.
Yeah.
I'd probably lower the firing temperature on it, to bring it into control, but.
Yeah, I mean the thing is, it's not like we're only firing yellow salt.
Right.
So then you're lowering the fire temperature for our 8 other glazes or whatever it is.
Right. Yeah, and that's always the problem with the studio.
Yeah. So. Yeah, so I look at this glaze and I'm like, oh, it looks fine.
Yeah, and that's it. And it's that whole thing about sort of learning interpretation, learning how heat is working, little tweaks here and there, and sort of going, oh, except we're in a community kiln, so whatever the temperature is what the temperature is.
Yeah.
Obviously, if you're doing your own firings, you have all that control, and
Yeah.
Then you can tweak things specifically.
I think I'm in a position where if I was like, I think we should change this glaze a little bit, and I did some testing, the professor would be like, yeah, it looks like it works better. I don't think she would care.
Yeah, I'd bring up I'd probably double your clay level.
Yeah.
And it'll go more matte, and you'll bring up the glass former, so it should run a little less. It's slightly overfluxed. I mean, you're a little high on the R20, Theoretically, you could bring down the Nefsi. That's probably going to take you out of the matte region, though. But yeah, play around with it. You guys all have the skills, and that is one thing I would like to say as we move towards the end. Of I hope you guys are feeling more confident about having the skills. There's always going to be glazes out there that are weird and wonky. There's always going to be things that you're going to question, and that's fine. But hopefully you're coming to a point where you at least feel comfortable looking at something and beginning to interpret, because it's about learning to read a new language and starting to see where that is. So Sandra, did you have any questions? You're just sitting politely.
I will once I'm able to set up my studio again. I just moved back to New Mexico.
Okay.
So I wish I had a studio during this class, but I'll do some testing later on.
Cool.
Is this our last hangout?
It is, unfortunately.
Oh no. Sad.
Yeah. But I'm always available. I mean, if you've got questions, I may tell you. It's not abnormal if you email me something to say. I will write you back and say, email me again in 2 weeks. I work on a time delay, but sorry, my dog is fussing. But I'm more than willing to help people, especially if you guys are following your own testing and doing all that sort of thing, or questions to answer. Fred, did you have any questions? Oh,
No.
No, you're good. You learned everything. Excellent. Scott, did you have any questions? Any more?
No, just one thing on the exam. I looked at it today.
Say again, on the what?
On the exam.
Oh, right.
The UMF calculation. You had the Excel spreadsheet thing there.
Mm-hmm.
What are you supposed to put in the boxes? Do you want the little equations like percentage divided by percentage or multiplied, or
Just
you
the
want
numbers?
Just the numbers? Okay.
Yeah, I know what they're doing, as long as you've got the right numbers in the right boxes.
And we just use, what is it? Or actually, you've had the chemical breakdowns. We're not using this,
No,
right?
yeah, use the chemical analysis on the sheet. That way I know everybody should get the same result, and I don't have to actually do everyone's math individually.
Okay.
Anybody else? Phyllis, you're good?
I'm good.
Okay. So, you guys, here's the part with my ruthless sales pitch. Thank you for taking Glazes 1. Please come back for Clays or Glazes 2, which will both take place this summer. The thing I would ask, actually more than that, is if you enjoyed this experience, I would actually ask a major favor of you. Later this week, I will send out a link with some contacts for my dean and my department chair. This is a new thing that we're trying to do, and if you guys have gotten value from this experience, it helps for them to know. I have put a lot of blood, sweat, and tears into this, and it's still something that can be a little bit controversial for the department. The other thing is, if you enjoyed this experience, ceramics is a small community. Tell your friends. Tell Facebook if you are on Facebook, because honestly, that's, I think, where most people find out about it, was from Facebook. A few of you I know I talked to individually here and there, but please spread the word. This is, it has... it has the Alfred behind it, but it's really just me trying to make this happen with this class, with the Clays class, with the Glazes 2 class, which will come up this summer.
I have a question about that.
Yeah.
So it's fairly clear that you don't have any video editing skills. No offense.
No, it's true.
Which, I don't have any video editing skills, so if I were in your position, my videos would be very similar to yours.
Right.
If Alfred were to put more energy behind what you do, would something like a video editor be something that you could get out in the future? If we're like, this was a great experience, the digital videos are awesome, is that going to give you more resources?
I would hope so. I mean, honestly, the first time I taught this class last year, the way that it happened was they had said, hey, anybody want to do an online class? I said yes. I was literally the first person in the School of Art and Design to ever do one. And I said, okay, I'll do it. And that was it. There was literally like nobody said anything about how you do it, how you record it, how you even host it, anything. And it's literally me figuring out everything as I go. I know that the videos can be rough. I know, it wasn't even like my whole thing has been to the university. Like, you need to make laptops and microphones and give those to the online faculty so that they can just go and do it. But like right now, I'm on all my own equipment. Well, actually, no, I got the art department to buy me some equipment finally.
Yeah.
That's why I've got my fancy microphone.
Yeah, I think that's the number one step to make your videos more professional.
Mm-hmm. No, absolutely, absolutely. And of that, if there were resources in the university, that would be great. But it's all sort of new and learning. But
but your whole Allen term is all online courses, correct?
Mm-hmm.
So it is something that the university is moving towards.
Yes, there was growth from last year to this year, and that there was growth in this class. I almost doubled the number of students. We had 24 people in this class. Obviously, not everybody shows up to the Hangouts, but that there's definitely interest out in there. I know that there's challenges and figuring out the online interface and technical challenges with doing Hangouts and all these types of things, and hopefully as everything gets worked out, it gets better, and working on things like that. But yeah, I mean, if you have enjoyed the experience and if you've gotten a lot of it, please tell everyone you know. Because it's just me doing. If you found out about it, it's because I know if I put a flyer in your hand or you saw a post on Facebook, it's literally just me trying to get attention. And I hate having to be the guy going out there and pitching it, and your word goes so much farther in the community than my word. I'm passionate about this stuff, and there's a lot of bad information about materials out there, and I'm trying to correct that. And it's hard, but you only can do it one person at a time. So I will send out an email with that sort of request. There's a course evaluation. Yara says she's sending questions. No, I haven't. So I really appreciate everybody here participating. I hope you guys learned a lot. I mean, that is my main goal. I hope you have a completely different perspective on glazes, or you have an understanding of glazes, which you may have not had before. There's always more to learn. There's more to explore, more to interpret and to test and to try. I know stuff like the online of not being able to necessarily test, like you're saying, Sandra, of that you just can't get in the lab and you're relying on this and that, and it always works better if you see it in person. But it's funny. Of two of my previous students were on Facebook today saying that they've given up making pots because all they're doing is testing glazes now. Like, I love that. They don't even care about the pots anymore. One of them was saying, I'm just going to start slip casting everything so I can make more surfaces to test more glazes on. Like, that's awesome.
Matt,
Yeah.
Will you send out something when the summer classes open up?
Yeah, absolutely. Actually, I think they may technically be open now. For registration. The short version is okay, so starting May 16th, there will be Glazes 1, which you guys have all obviously taken, and Clays 1 will be offered May 16th, and it's 5 weeks. So if you're interested in Clays, it will be offered May 16th. Then, on June 27th, there will be a second offering of Glazes 1, a second offering of Clays 1, and Glazes 2. Okay, so if you're interested in Glazes 2, that's only going to be June 27th.
Okay.
And again, 5 weeks until like August 5th, I think.
If we go look at Alfred's website to find these things, is it another Allen term? Do they consider that an Allen term, or is
no?
it
It's summer school.
Okay.
So it's different. And do we have all the questions answered? Should I stop the broadcast and I can say things not on video?
What?
Okay. I'm going to stop the broadcast.